Hello there. This video will show you how to perform a t-test, well actually 3 t-tests for independent samples and 3 one-way ANOVAs to examine the significant differences in perceptions of job applicants based on whether or not recruiters heard an audio recording or read a transcript of them presenting themselves in a job interview type of situation. You'll notice that the article that we're using for this Excel assignment is the same that you used for the first Excel assignment, only this time we're not just going to compute descriptive statistics and do tables and figures, we're actually going to perform the hypothesis test to see if there are significant differences in perceptions of job applicants based on which condition the recruiters were in. So you'll see that this explanation is very similar to the study overview that you had in Excel Assignment 1. We are also referring to Experiment 4 in the Schroeder and Epley study. So if you want to follow along with me in the journal article, you can click the link to get the journal article, and you want to go to page 887 because that is where Experiment 4 begins. So essentially, we are going to run the t-test that you see presented here. So we're going to do a t-test to compare let's see, intellect ratings based on whether or not the recruiter heard an audio recording or read a transcript. Also, we're going to compare the impression ratings. And then finally, we're going to compare the hiring ratings. And you'll see those t-tests recreated. Now remember, you can do an ANOVA or a t-test if you are comparing two groups. And we are comparing two groups here. We're comparing the audio and the transcript condition. So in addition to showing you how to recreate the t-test that you see here, I'm going to show you how you could have used an analysis of variance and you'll get the same results. You won't get the same test statistics, but you will get the same p-value and you'll be making the same conclusions with either the t-test or the ANOVA. Now keep in mind that Excel does not run Tukey's post hoc analysis. SPSS does, but we're not using SPSS in this class. We're using Excel. So if you were to do an ANOVA in Excel and you had more than two groups, instead of running a Tukey in Excel, you would actually see if the overall finding for the ANOVA was significant. And if it was, you would do a series of t-tests for each pair to see which specific groups are significantly different. So just keep that in mind as we go along. All right, so let's go ahead and take a look at your assignment. So the first thing we need to do is make sure that the data analysis tool pack is installed. I already have it installed, but just in case you're on a computer that does not, I want to show you how you're going to do that. So you're going to be working in the Excel assignment 3 data. You'll also see that in the Excel assignment 1, we created these mean scale scores here, but I'm just going to give you a version of the data with those already created. You'll also see the hiring rating and then the condition here. Now keep in mind, I already organized this data so that the first section just has the data for the transcript condition and the second section has the data for the audio condition. If this wasn't already done for you, you could highlight those conditions, and you'll see why this is important in a second, why they need to be organized. You could have highlighted those conditions, go to Sort and Filter under the Home tab, and you could have sorted from A to Z, and it would have put those in order for you. And just make sure if you ever have to do that, that you click Expand the Selection and click OK. But I already did it for you. So now let's go ahead. I'll show you how you could download the Data Analysis Tool Pack if you don't already have it installed. Okay, so you go to File, Options, Add-ins. You want to click Analysis Tool Pack. Make sure you click Go down here. Make sure Analysis Tool Pack is checked and then click OK. And then when you click on the Data tab, you'll see this Data Analysis option there for you. Okay, let's take a look at the assignment again. All right, so now we need to organize our data to prepare it for a t-test and an ANOVA. So the way that you do this is you want to have each condition represented and below each dependent variable represented, so intellect, impression, and hire. And below each dependent variable, you want to have each condition and then the scores for that dependent variable below each condition. So I'll show you exactly how you need to do that. So let's go ahead and start by labeling each dependent variable. So I'm going to click Intellect Rating, right-click, Copy, or you can hit Control-C. And I'm going to go over here to G and just hit Control-V to paste, or you could have right-clicked and done this as well. So Intellect Rating. Now I'm going to go ahead and scoot over 1, 2, 3, 4 spaces to K and put impression rating. Control C to copy, Control V to paste, and I'm just going to double click. Then 1, 2, 3, 4 to O, higher rating, Control C to copy, Control V to paste. Double click. Now I'm going to take each condition and label it below. So Control C, Control V, transcript, Control C to copy, go over here, Control V for audio. Now because we've already done this, let's go ahead and just copy these and do Control C to copy, then Control V to paste, then under here Control V to paste. Now if you want to be fancy and center your dependent variable above your groups, you can highlight those, go to the Home tab, merge and center. Highlight these two, merge and center. Highlight these two, merge and center. It's up to you. I also like to have everything centered, so I'm going to click this little arrow up here. Under the Home tab, click the little everything in the middle center button, and now it's looking pretty and I'm comfortable with it. Okay, so now what we need to do is we want to have all of the intellect ratings for the transcript group here and all of the intellect ratings for the audio group here. All of the impression ratings for transcript here, impression ratings for audio group here, higher ratings for transcript here, and higher ratings for audio group here. You'll see what that looks like. So here's our intellect ratings. So I'm just going to copy down to that last person in the transcript group, hit Control C to copy, and pop that right here. Now I need to get the intellect ratings for the audio group. So highlight for the audio group, go all the way down. See how that corresponds to the people in the audio group. I just hit Control C to copy, go right below audio, Control V to paste. Now let's do the same thing for impression. So you're going to copy all the impression ratings for the transcript group. Control C to copy, Control V to paste. For the audio group, highlight all those. Impression scores, Control C to copy. Go right here, Control V to paste. Now we're going to do it for hiring. Highlight all those groups, or all those hiring scores for the transcript group. Go over here, Control V to paste. Over here, highlight all these hiring ratings for the audio group, Control C to copy, and Control V to paste. So now we have our data prepared for the analyses that we're going to run. I'm going to go ahead and save this too. Save as. And I'm going to save this as the key. All right. Make sure you save as you go because you would hate to lose all your work. Okay, so now let's pop back into the assignment. So the first thing I ask you to do is compute the sample standard deviation for each rating within each group to justify running a t-test assuming equal variances. So you'll see in Excel there's two options for the t-independent samples. One t-test assumes equal variances, or in other words, assumes that the scores within each condition have roughly the same spread. There's another t-test assuming unequal variances that's different than the one we've been doing by hand, and it uses this correction formula to account for the fact that the two conditions don't have an equal spread of scores. Now, the way that you determine whether or not it's equal enough to run the equal variance test, you see if your standard deviation, if one is 4 times larger than the other or more than that, then you know you can't assume equal variances. But as long as they're pretty close, one isn't more than 4 times bigger than the other, then you can run the t-test assuming equal variances, and it's exactly like what you've been doing manually in class. So let's just real quick justify using that type of t-test. So I'm going to go down here and I'm just going to type in, and I want you to do this in your worksheet as well, SD equals, just so I remember what I'm computing. Right next to that, click, and you know what, real quick, let's go ahead and freeze this pane so we can still see what's at the top. So go to View, Freeze Panes, Freeze Top Row. Now check this out. See that dark bar that just went across the top? When I scroll down, I can still see what I'm working with, which is kind of nice. All right, so equals STD, it always cracks me up. I know that's dirty, but whatever. Okay, so STD, and then you want stdev.s, double click, standard deviation for the sample. Now go ahead, because we're going to copy this formula over and we don't want it to miss these values. Go ahead and start right here. Even though there's no data, it's okay. We just want to make sure that it's going to get to the bottom of the other condition. Just highlight all those numbers right there. Click enter. Now we can click, go down to the bottom right where you see the little plus sign, and just copy that formula all the way over. Now you'll see in the columns with no data, it gives you a little error message. Just get rid of those. And now we have our standard deviations for each different group. If you go back to the journal article and you look at these standard deviations, you will see that they are the same as what we have in our Excel worksheet. Now we can figure out, is it appropriate to assume equal variances? And yes, it is. These standard deviations are very close. This one isn't 4 times bigger than this one. None of these are 4 times bigger than the other, and none of these are 4 times bigger than the other. So we've justified running that t-test for independent samples assuming equal variances. We're finally ready to actually run the t-tests, because that's what you're going to need to do for number 1. Now you're going to notice that for each of these questions, I'm going to ask you to paste the output below. So make sure that you're doing that. Also notice that for the first one, I'm going to ask you for the t-statistic and explain it, the critical value, the p-value and explain it, and then how you know your decision. I'm going to give you these answers in the video. But for the next ones, I'm not going to ask you to explain T or P, because I'll assume if you can do it here, then you could do it here. But you are going to have to determine which decision should be made, and you need to explain based on both the T critical, how does it compare to T observed, and the p-value, how does that compare to your alpha level. So take the answer that I give you for this one and apply it to this one and this one. You also notice the same pattern for the ANOVA questions, where I'm going to ask you to explain everything, and I'm going to tell you in the video how to explain it, but then for these next ones, you're just going to have to tell me which decision you would make, and you're going to have to do that on your own based on the information that you learned from Part E up here. Then finally, you're going to do this one on your own as well, where you need to take the results, think about them, and think about what does that really imply about hiring practices after you succinctly and in plain English summarize the nature of the results. So what are the results? It's plain and simple. And then what are those results? How will those inform hiring practices, or how should they inform hiring practices? So now let's go ahead and I'm going to show you how to do all of these t-tests. I'm going to give you the full explanation for this, and then you're going to have to explain these other two on your own. So let's go into Excel. Let's first run the t-test for intellect rating. So we're going to go to Data, Data Analysis. You're going to go to t-test to sample assuming equal variances, because remember our standard deviations were really close. So click that. Click OK. Now, if you look at our Excel assignment, our reference group is the audio group, right? We think that the audio group, they're going to have more favorable ratings across the board. So when you go into this, you want your variable 1 to be kind of the first variable mentioned in your hypothesis, or the first group mentioned in your hypothesis. So we're going to actually select audio as variable 1 and transcript as variable 2. So let's go ahead and click including the label, right? So for this first one, audio for intellect, all the way down to the last score. Okay. Variable 2, scroll back up, the intellect ratings for the transcript group. Make sure again that labels is checked. Then for your output range, let's go ahead and put our output right here so that we'll be able to know that it's part of the intellect group, because it's not going to tell us. So again, just remember that before you click that, you've clicked here so it doesn't mess up your other values. All right, let's click OK. Okay. Now let's run each test before we explain them. So let's go to Data Analysis. We're doing a t-test assuming equal variances again. But now, make sure you click the little data so it'll let you navigate through the worksheet. We're going to select the audio scores. I deleted that. For the impression rating, just highlight those. Now you want to get rid of this. And for variable 2, we're going to highlight the impression ratings for the transcript group. Labels is still selected. We want this to go into a different output range, so delete that. And then just go ahead and click right here. So we know we're looking at the impression t-test, and click OK. Now for higher rating, let's run that t-test again. You're going to be good at this by the time this is over. Data Analysis, 2 sample assuming equal variances, because remember those standard deviations were close. Click OK. So now for variable 1 range, delete that. We're going to highlight the higher ratings for the audio group. And for variable 2, delete, we're going to highlight the transcript ratings, or the higher ratings for the transcript group. Labels, 0.05, output range, delete that, and stick it right here below your higher rating values. And then just click OK. Now let's go ahead and take a look at this. So we've got all of our values here. If you want to round them to the thousandths place, you can. Just highlight. Let's see if it'll do it for all of them. Highlight all this stuff. Right click, format cells, number, thousandths place. Oh yeah, that's beautiful. Okay, so now let's take a look at this. Remember, for this first one, you have to give me the value for the t-statistic and explain it. So let's do that. So here, just like when you did the repeated measures t-test, you see your means for each group, or your average. The variances are here, and check this out. Remember, the variance, if you just take the square root of the variance, so squirt, you get the standard deviation. Check it out. So just some extra knowledge for you there. Also, the number of observations, there was 21 people in the audio group and 18 people in the transcript group. Here's your pooled variance if you computed that. That's going to be 0 across the board. That's your hypothesized mean difference. That would be the second part of the t formula in the numerator that I have you ignore. Here's your degrees of freedom. 21 minus 1 plus 18 minus 1. Here's your t-statistic. This is your t observed. And remember, this value tells you that the actual difference in means for intellect rating between the audio and the transcript group is 3.526 times larger than the difference you'd expect to see in intellect ratings just due to random sampling error or just due to random chance. So remember, this tells you that your numerator is 3.526 times larger than your denominator. The numerator is the actual mean difference in intellect ratings between audio and transcript, and the denominator is your standard error, or the difference you'd expect to see between these two groups, no matter what, even if audio versus transcript had no impact on intellect. Even if you just randomly had 21 people and 18 people, had them rated, and they weren't in different conditions. This is the difference you'd expect to see just due to chance. Now be careful when you start to look at these p-values and these t-crits, because this is a one-tailed test. So up here, we're being specific. We think the audio condition is going to have higher intellect ratings than the transcript group. So we're being very specific about the nature of our hypothesis here. So it is a one-tailed test. So when we look at our p and our t, we are only going to focus on these because it's a one-tailed test. So we see here that our t-crit is 1.687 and our p-value is 0.001. What this p-value tells you, so you can answer this, is that the probability that you would have gotten this mean difference between audio and transcript groups just due to chance, the probability of that happening is less than it's 0.001, or in other words, 0.1% chance that you would have gotten this mean difference just due to sampling error. Now remember, when you make your decision here, there's two things you must consider. So the first thing, if we're going to fail to reject or reject the null, you want to compare the p-value to your alpha. And remember, our alpha level was 0.05. And so we were willing to accept a 5% chance that these two means were different due to sampling error to still call it significant. But here, we only have a 0.001% chance, or 0.001 probability, or a 0.1% chance that that's just due to sampling error. So because our p is less than our alpha, we can reject the hoe and conclude that there is, in fact, a significant difference in intellect rating between the audio and the transcript groups. Now, you also know this based on t-crit. If you drew out this distribution, we're going to only look at the high end of the distribution because we have a one-tailed test. We're expecting a higher mean for the audio group. Our t-crit is 1.687. And our t-stat of 3.526 is way out here. That also tells us to reject the null. So make sure that you're ready to apply that logic of how you make that decision for this t-test and this t-test as well for your assignment. Okay, so make sure that you paste your outputs that I helped you create here, and then be sure to answer part B on your own. Now let's take a look at a one-way ANOVA to see if we get similar results. And remember, again, you can run a one-way ANOVA if you're only comparing two groups, but if you have 3 or more groups, you cannot run a t-test to start with. You would have to do a one-way ANOVA, and then in Excel, you would use t-tests for your post hoc analysis. But I just want to show you how to run an ANOVA and show you that you should probably get similar conclusions with the t-test or an ANOVA if you're comparing two groups. Now note that your null and alternative hypotheses look a little bit different now because we're doing an ANOVA. And for ANOVA, even if you just have two groups, the null is still mu equals mu, however many mu's you have, and then the alternative is always at least one mu is significantly different. So let's go ahead and run all the ANOVAs in Excel, and then I'll show you how to answer these questions, and then I'll let you answer the part B's and 7 on your own. So let's pop into Excel. And we're not going to be able to put our ANOVAs under each one of these because the output is really wide. So let's go ahead and just start off by first labeling this. I'm going to hit Control B to make it bold and put intellect right here. And then when we do our output, we're going to click this cell to put the output right there. So let's scroll up to the top, data analysis, go up to the top, ANOVA single factor, click OK. Our input range this time, we're just going to go to audio or transcript and audio and highlight all that data at once. Click labels in first row. Under output range, click that and then make sure you click the box next to it. And just click the little box below intellect and click OK. Now let's do it for impression rating. So let's scroll down a little bit. Control B for bold, impression. I'm going to scroll up to the top. Data analysis, single factor ANOVA, but now this time our input range, I'm just going to delete that, is under the impression rating. So just highlight all of that stuff, all those scores. Change your output range to be below where we put impression. So let's scroll down, click that, OK. Now let's do it for higher rating. Control B to bold, just so it stands out, higher. Go to data analysis, click out of there. Data analysis, single factor ANOVA, OK. And we're going to highlight, delete this, all the scores for higher rating for both groups. For our output range, we're going to delete that, go away, click the little box under higher, and click OK. All right. So now let's take a look at this first output for intellect, and that's the one that I'm going to explain the most thoroughly here. So this is our summary statistics. This tells us that there's 18 people in the transcript group and 21 people in the audio group. And you see that that is mirrored up here. These are the sums, so the total score, if you added your sum of x for each group. Here's your means, or your average, and here's your variances again. And you'll see those mimic what you see here. Now for the ANOVA, you get a source table. This whole part is just like what I've been having you do by hand. So you'll see you've got your sum of squares between, your sum of squares within, and your sum of squares total. Your degrees of freedom 1, or your degrees of freedom between, right, k minus 1. Two groups minus 1 is 1. Your degrees of freedom within, which is n minus k. There's 39 minus 1, or two groups gives you 37, and then 1 plus 37 is 38. You've got your mean squares between. This divided by this is this. Your mean squared within, this divided by this is this, and then your F statistic, this divided by this gives you F. Now the source table in Excel also gives you your p-value and your F critical. So let's talk about these values for a second. So I first ask you, what's the value for the F statistic and what does it tell you? So remember, the mean squared between it represents all the differences in this case, intellect ratings. That's due to both the independent variable, which group people were in, audio versus transcript, and due to error, so just chance differences. This mean squared within just represents the differences in intellect ratings between the transcript and audio group just due to random chance, just due to fluke differences. And remember, this within group differences is the error because within this group, there's differences, right? There's differences in intellect ratings, but we know that's not due to the independent variable because they all read the transcript. Within this group, they're not all the same scores. You see differences, but that's not due to the independent variable because they all were in the audio group. So these represent those random chance differences that didn't occur due to which condition they were in, and that's really overall what this number represents. So now let's think about the F statistic. What the F statistic tells us is that this is 12.432 times larger than this. So in plain English, as plain as we can get, the differences in intellect ratings due to both which condition participants were in and due to random chance is 12.432 times larger than the difference in intellect ratings just due to random chance. So this is an impressive F statistic. In fact, it justifies justifies the decision to reject the null because our F crit is much lower. So if I draw this out, F crit is 4.11-ish. And this F statistic is way out here. So that tells us we can reject the null. Our F stat is greater than our F crit. Now let's talk about the p-value for a second. So the p-value here is 0.001144. And this tells us that there's only, if we multiply this by 100, a 0.1% chance, 0.1% chance that the differences observed between the two groups is just due to sampling error. So we're really, really confident, 99.9% confident, that the differences that we observed here are actually due to the condition that the people were in, not just due to random differences. We also, the p-value tells us to reject the null because 0.001, or p, is less than 0.05 alpha. So now I've given you pretty much all the answers here, and apply what you just learned to answer part B for number 5 and part B for number 6. And then I want you to do number 7 on your own. Now, before I let you go, I just want to make sure that we did this right and compare our t-statistics to the journal article. So I'm going to go ahead and drag this over here. So I'm just going to drag it, and let's go ahead and actually, we'll minimize this. We're going to drag the Excel assignment over here so we can look at our t-statistics. And then let's look at the journal article as well. So if we go here, I'm just click and drag this over here and go over to the results section. Now check it out. The recruiters believe that the job candidates had greater intellect when they listened to pitches, in other words, audio, than when they read pitches. If we look here, intellect, T, stat 3.526. Bam. P less than 0.01, there you have it. Let's go to the next one. So they also saw that they had more positive impressions of the candidates and when they listened to pitches, audio, versus when they read pitches, transcript. Check this out. T equals 2.85 and P is less than 0.01. Over here as well, they were more likely to hire the candidates when they listened to pitches or audio than when they read the transcript. And you see again, T of 2.62 and P less than 0.01. So we did it right, and now I can end this video.